Hello everyone. Today we will solve valid parenthesis problem on LeetCode. Let's read the problem statement first. I will take the problem statement to the drawing board. So, given a string S containing just the characters, parentheses, then curly braces and square brackets, we'll have to determine if input string is valid. An input string is valid if these three conditions are satisfied. What are the conditions? Opening brackets must be closed by the same type of brackets. That means if a string contains this first bracket, then the closing bracket has to be the same types. Then the second condition says opening bracket must be closed in the correct order. Okay, so if multiple types of bracket occurs, for example, if the if first the parenthesis occurs, then the opening curly braces, then the opening curly braces will close first, then the parenthesis will close. Okay, so these orders should be maintained. The third condition says every close bracket has a corresponding open bracket of the same type. That means the string cannot start with a closing bracket. For example, suppose a string start with the ending square brackets, right? Ending square brackets. This cannot happen. Before any ending bracket occurs, there has to be a starting bracket of the similar type. So the third condition means this. Let's analyze the test cases now. In the example on, they have given this string which starts with opening parenthesis and close parenthesis. So as you can see, it is valid because the string starts with an opening parenthesis and ends with an closing parenthesis. Now in the example 2, they have given this string. Okay. This one is also valid as the opening parenthesis starts and it is closed. Then square bracket starts and it gets closed. Then curly braces starts and it gets closed. Thus it is a valid string as it satisfies the whole three condition. Now in the example 3, the string is opening with an opening parenthesis but immediately ending with an square bracket, which violates the rule because the string started with an opening parenthesis but it never got closed, right? Now let's analyze the last test case. They have given this string. Okay, so one key thing to notice here is that first let's check if this string is valid. All right, so the string starts with an opening parenthesis, then opening square bracket occurs, then closing square bracket occurs, and this part satisfies the condition. Then the opening parenthesis gets closed here. Okay. So one key thing to notice here is that uh, we have just checked that this is an valid string, right? Now one key thing to notice here is that if there exists a valid string, then there will be substring of that string which is also valid, right? Which means if we remove this substring from the initial string, the remaining string will also be valid. So we will use this exact property to solve this problem efficiently. Now what we will do is we will iterate the string from left to right and store the strings in a stack, right? Stack. Why we are using stack? It will get cleared when I fully explain this test case. Okay. Suppose the given string is this. Okay. So we will follow a specific technique. When an opening braces occurs, basically when opening type of parenthesis occurs, we will push that string to the stack. So let's first mark the indexes of this string 0, 1, 2, 3. right? So at the first at the first index, the opening parenthesis occurred, so we push that opening parenthesis to the stack. Okay. Now at the second index, opening square bracket occurred, so we will push that is opening square bracket to the stack. Right. So then at the third index, zero-based indexing, then on the third index, we are seeing that a closing square bracket occurred. Right now, as I have said from this part, if any valid string exists, then a substring of that string will also be valid. That means we can remove this part, right? So what we will do is, we are seeing that the we are getting a closing parenthesis and there exists the opening parenthesis right before this closing parenthesis, right? So we will remove this opening square bracket from the stack, right? Because of this closing square bracket. Okay. Then on the third index, we have the closing parenthesis, right? So that means we'll remove this opening parenthesis from this stack as well, right? So thus our stack will remain empty at the end. So this is for valid condition. If our stack if our stack doesn't remain empty, then that means the given string is not valid. Okay. So let's analyze this from a false test case. For example, here we had been given the string which starts with opening parenthesis. Okay. So as it is opening parenthesis, we will push that into the stack. Now a closing parenthesis occurs, but we don't see any opening square bracket against that closing square bracket, right? So that means our iteration ends here, but the stack is not empty as it contains the opening parenthesis, right? So the stack is not empty. Thus, this is an invalid parenthesis. So this will be our approach. Now let's summarize the exact algorithm that we'll use. Okay. Let's see the exact algorithm now. If any opening type of parenthesis or bracket occurs, we will push that opening type of bracket into the stack, right? Then if any closing type of bracket occurs, we will check if the opening type of bracket exists in the top of the stack. Okay. If same type of opening bracket exists and the stack is not empty, right? We will pop that opening parenthesis from the stack, then proceed to the next step with the next iteration. Otherwise, if there doesn't exist similar type of open bracket into the stack, will return false. Okay. So this process will continue until the end of the string. Then in the end, if our stack is empty, the parenthesis is valid, otherwise the parenthesis given is invalid. Right. So this will be our exact procedure. Let's see the code part now. Okay, so initially we have been given this is valid function and the string s. Okay. So we will have to return if this string s is valid. So according to the algorithm, we have first taken the stack, right? Then we have taken a map. What I have done here is I have mapped the closing brackets with the opening brackets. This basically represents, suppose the map name was MP. This basically represents MP of opening, sorry, MP of closing parenthesis is equal to opening parenthesis. Okay. So this part is just to make the implementation a bit easier. Okay. Then we are iterating the array from left to right. If any opening parenthesis occurs, we are pushing that parenthesis bracket into the stack. Then now if our stack is empty and the top of the stack does not matches with our current type of closing parenthesis, right, then we are returning false. Otherwise, in this line, if the closing parenthesis matches the opening parenthesis that appears in the top of the stack, we are just popping that value and proceeding to the next iteration. So in the end, if our stack is empty, we are just returning true, otherwise returning false. Okay. So this is just a shortcut version of returning that statement. Alright, so let's submit the solution now. So it gets accepted. Now let's talk about the time complexity. Okay, so we are using a stack and a map, right? So this map basically contains just three elements. So it will be kind of uh, O of log of 3, right? So the map part will be O of log of 3. This is basically O of 1, right? Then in the stack part, we are iterating from left to right in the size of the string, right? So this is basically O of n, right? So the final complexity is O of n. Now, what about the space complexity? The map just contains three elements. So again, I will ignore that part. Stack contains at least the stack contains at least n by 3 elements if the string is valid, right? So we can just say this is basically O of n, right? So the space complexity is also O of n, the time complexity is also O of n, right? So that's it for today. See you next time.